Exercise 21.3, question 4, part 6. So, in this question, we're looking at the situation where the ball is kicked from ground level and 20 metres away, there is somebody standing. So what we want to work out is this height here. So when the horizontal displacement is 20, what is the vertical displacement, which I called y? Well, from earlier in the question, we know that the initial velocity u as a vector is 19 cos 25, 19 sine 25. And we know A is 0, negative g, because the only force acting is gravity. And then r as a vector, well, we know the horizontal component of r. We know the horizontal component of r is 20. And what we don't know is the vertical component of r, which we call y. So again, we're going to use r equals r0, but remember r0 is the origin here, so we don't need to account for its initial position. R equals ut plus a half a t squared. So putting all of these vectors in, we're going to get two equations in t. We're going to get 20 and y equals 19 cos 25, 19 sine 25, all multiplied by t, plus half of 0 minus g multiplied by t squared. So if we take the horizontal component of that vector equation, we end up getting 20 equals 19 cos 25 times by t. So just rearranging that for t, that gives us t is 20 over 19 cos 25. I'm just going to leave that as that. I'm not going to bother working out exactly what that is in numerical form. Well, now if we take the vertical component of the same thing, we're going to get y equals 19 sine 25 times t minus g over 2 t squared. So let's write that out. Y equals 19 sine 25 times t minus g over 2 t squared. But we know our value of t now. We can substitute in our value of t, which is our 20 over 19 cos 25. We get y equals 19 sine 25 times by 20 over 19 cos 25. So over 19 cos 25 times by 20 minus g over 2 lots of 20 over 19 cos 25 all squared. And if you just type that into a calculator and work it out to 2 decimal places, that is 2.72 meters. And the last part of the question says, can she stop the ball? Well, thinking about what the height of a person is, the average height of a person is going to be about 1.65 meters probably. So that ball is at least a meter above that person. Potentially with a hockey stick, she could stop that ball. I don't know if you're allowed to wave your stick above your head in hockey or not. But to reach a height of 2.72 meters is conceivable for a human, but perhaps not.